now is the time to cover 3 different areas of within AWS basic services. The first one is AWS SQS service. Then we will talk a little bit about SNS service. SNS is the simple notification service within AWS. And the last thing we'll cover today at a high level would be serverless architecture. And within that, we'll cover a little bit about AWS Lambda services. So these are the 3 areas that we will try to cover in the next 45 minutes window. If you do have any questions, like Shane said, post it please on the chat window. And Shane, you can probably stop me and ask a question as they come, or maybe we can answer them at the end. So. All right, having said that, the first topic that we would like to cover is AWS SQS service, and that is the simple queuing service that is available from Amazon. The SQS basically stand for Simple Queue Service. The idea behind that is to decouple your application. Okay, I've been really a big proponent of using SQS when it comes and when I'm doing a comparison between the cron jobs and a thread between 2 applications that are coupled tightly versus whether we can use SQS queuing services. So whenever there's an opportunity where you can decouple your application, you should definitely do that, right? And there are different ways, right? You can have your microservices architecture where you have small services that can actually just do one small job and that's it. And then this way you can build those microservices. They can actually they can run faster. They can be easily upgradable, replaceable, and there's a less dependency on other services, which could be in a monolithic application. So when you're decoupling, you may want to probably also think about the queuing services, the SQS, which allows you to actually put your request on a queue. You forget about that. You basically, you're not really tying one-to-one applications for the duration of the request response, rather than you're just throwing a request and hoping that, okay, the response is going to come back. With the SQS, and this is not a new concept, right? So if folks are familiar with IBM's queuing services, MQ services, Apache had that as well as an open source. These are the services that within the queuing application that has existed for quite some time, and people have taken advantage of it. We have applied that within our application before even Amazon SQS came out. We use Apache's queuing services, MQ series, and IBM MQ series is also pretty good. But within Apache, they also offer the active queuing services. With that, you can actually, again, drop your message to the queue, and then as a publisher, and then the consumer on the other end is basically receiving that message and then start consuming it. That becomes very handy when you are especially dealing with the large request that needs to be processed. For example, if you have a lot of images or a batch file that needs to be processed, you don't want to tie up your server and have that connectivity, a session connectivity between your client and server until the whole batch processing of the file or maybe the image processing is done. What you do rather is just say, okay, well, drop the request on the queue, and then the consumer would actually pull it up from that queue and then would actually serve it. And once that is done, then you can also have a notification mechanism where you can notify to your consumer, to your client saying, hey, your request has been processed. That can be done several ways. For example, you can have an email services that can be used. You can have a message within a dashboard or notification within your dashboard of your client application that says the job that you requested has been done. Or even you can tie it with the SMS as well. So you can send a message, hey, the job that you requested has been done. The whole idea is to decouple your application from having a monolithic service where basically it does everything on the fly. Rather than doing that, you can probably just have the services distributed to your SQS server, which is easily available from Amazon. Just give me one Sorry about that. So the SQS within Amazon also, what it's called is works on the fan-out approach for multi-level queuing, right? And you will see it from the diagram that I have it and during the PowerPoint presentation. So fan-out approach allows you to actually distribute your requests to different servers, and then anyone can pick it up. Once that is all processed, then it can be received from the servers that has been distributed to. So it's horizontally scalable, right? So you are not really relying on just one server, which basically serves all those requests, but rather than you are having a fan-out approach where you send the services to different services, the farm of services, and then basically get processed. The third good quality within the SQS is basically drop a message and forget it, right? 99.99% is guaranteed to be delivered, right? Which means that once you have the message in a proper format, again, that will be your responsibility. But once the message has been properly constructed, then you can drop it on the queuing service, and the queuing service is guaranteed to deliver that message to the consumer. Then at least it guarantees one-time delivery of the message. So again, the drop a message and forget it guarantees one-time delivery kind of go hand in hand, where basically you're dropping the message, and again, because of the fan-out approach where you have multiple servers within SQS Amazon, it is guaranteed that the message will be delivered. Can set up as a FIFO now, which means first in, first out, which was not available when I put together this presentation, but obviously it is available within the new services that has come out. All right. Within Amazon SQS service, there is a concept called delay queues and visibility timeouts. What the delay queues does is basically it allows you to postpone the visibility of a message on a queue. And that visibility of the message could be a maximum up to 15 minutes. So you can set a number between 0 to 900, and that gets translated to 15 minutes. So this means that you want to make sure that when you drop a new message, it gets consumed only after 15 minutes, right? So that is what the delay queue means, right? And that is something that Amazon provides you, where you can drop a message and you want to make sure that you give enough buffer, 15 minutes buffer, before that message can be read by the consumer. That again could be different approaches within your application, where you want to make sure that your message that gets dropped from the client is read only by the consumer after 15 minutes, not before that. So if you have that kind of a request or that need within your application, Amazon SQS service has that by creating a delay queues and setting those time delay second attribute time to maximum up to 900, which translate to 15 minutes. All right. The visibility timeout is basically when how long the message will be visible for. So when you drop a message, and then you have a visibility flag, which basically tells this message will be available for this period of time, and before this messages are dropped into a dead letter pool. The dead letter queue is basically something which allows you to capture any of the messages that has not been served. And then you can do the same thing where you can consume the messages from the dead letter queue, where all the messages that were failed to be processed and can be picked up from the dead letter queue. So it's like a one level down from your main queue, where any messages from your conveyor belt, so to speak, was not picked up to be serviced. Then the next level down is basically dead letter queue, and then the message automatically drops to the dead letter queue. And then you can attach a service or a component or a code or an application, whatever you have it, that is connected directly to your dead letter queue, which can actually pull the messages from the dead letter queue and start processing it. Okay. Operations within SQS, what can you do? And this is something you can all easily do it when you are actually dealing with the either CLI or maybe just through the SDK, the code base. So what you can do, you can call the create queue, you can call the list queue, delete queue, send message method, get queue URL, and the list can go on. There are quite a few messages and operations that are available within SQS that you can easily use if you're writing a code, an application code to actually create the the queue or consume the queue. All of that functionality is available through the CLI, the client interface, or command line interface, or you can actually just make an SDK call to these queues and start consuming these methods. Amazon has done a really great job in terms of making sure that all of the functionalities that are available within all of those functionalities that are available within their interface, within their AWS interface, is also equally available through the CLI and then also available through the SDK, which gives you a full flexibility of control of the services that you are consuming, that you are using on Amazon. We are heavily using it here at Quick Start, the SQS services. Our use case scenario has been where we have long batch files of user data, right? So the user needs to be created, user needs to be inserted and enrolled in the different courses, and also user emails needs to be sent out. So when you're actually registering those large number of users into the system, and that batch file is uploaded from a manager for their, let's say, 500 or 1,000 employees, you don't want the system to just spin and then have the client just wait until the whole 1,000 records has been processed. You would rather probably have that done in the offline mode, meaning that you send it across and you hope that everything is going to get processed. So we do this through the SQS. So our, the file of enrollment of the registration of the user, it could be very large. That get sent over to our, gets uploaded to our system using our quickstart.com website. Once that gets uploaded, then that file is thrown onto the batch SQS service. Then we do have a consumer at the back end, which basically picks that file up as soon as it gets dropped into the SQS service and start processing it. Now, again, the processing includes the first time is reading the file, it's reading the records from the file, determining the size of the records inside of the file, registering all the users within the file, enrolling those users in a specific course program, and also assigning different sub-organization group for each member. So there's a lot of processing that gets done in the back end once the file gets opened up and then start processed. All of that is done by the consumer end from the SQS. So once the file gets dropped on the SQS service, then our consumer application code picks that file up and it starts processing it. Once that is done, then we know who the user was who dropped that file. We usually send an email to that user saying, hey, your file has been processed. And also we post it on their dashboard after they log in, saying the file that you uploaded has been processed, these many records have been passed, this many record has been failed, and these are the reasons for the failures. So it gives you a very nice report for a manager when they want to see how many data has been processed and how the file was processed in terms of passes percentages versus failure percentages. All of this is possible through the SQS. Imagine if you don't have the SQS, then you have to probably take the file, then you have to write a cron job. That's one alternative, right? So you have to take the cron job, create a cron job, which basically, first of all, you take the file, you keep it somewhere on a server, and then you have a cron job, which basically comes to live every 15 minutes or whatever the frequency is, goes to the server, pick up the file, and does the processing. Now it becomes, cron jobs are good, but I think if you compare with the SQS is much more real time. You don't have to wait 15 minutes. As soon as the file gets dropped, you can actually start processing it. And also you don't really have to set up a separate cron servers because SQS is already there within the AWS environment, so you can start taking advantage of Amazon SQS services. The other advantage is basically it's scalable, right? So you can drop hundreds and hundreds of files, and Amazon is a very robust and scalable solution. So horizontally, they would scale. So you don't have to worry about what if people start using my services a lot, and then the files that gets dropped on the SQS services increase. Then what happens? It doesn't matter because the Amazon takes care of it, where they increase horizontally, and then the SQS services are basically cope up with the demand. So these are the big advantages that keeping in mind, we have actually went into the SQS service and start processing those large files. The other case scenario that we have implemented here, quick start using the SQS, is the large images, right? So if people want, we do have a lot of courses, and courses have images. We want to process those images and attach those to the courses. So we, instead of doing those through the client server call, what we do is basically we start putting them on the SQS service, large image files, and those image files get again picked up the same process. All right. So hopefully you're getting some of the use case scenarios that would make sense, and I will actually walk you through on how to set it up on the SQS on Amazon towards the tail end of the SQS topic. But at least I want to make sure that you guys understand the use cases of SQS, the scalability of SQS on Amazon as well. The other attribute within the Amazon SQS service is long polling. Now, when you're actually your consumer, which is basically attached to your SQS service, which is actually looking and polling your, reading your SQS service to find out if there's a message that has been dropped that needs to be consumed. There are multiple ways of doing it. You can set a calls to queue on a periodic basis. Every 15, 20 minutes, you can make a call, and then it basically does that. You can have a call to queue in a loop, but will be costly on your server side. Instead, use a long polling. So you can have a for loop and it constantly read through these queue and see if the message has been dropped. But again, it would be very costly on your server. The other option is to use the long polling option within the SQS. Long polling allows you that when you make a call, it can wait up to a few seconds, and wait time seconds that can be wait time seconds is an attribute within the SQS, and that wait time seconds would be used when it's actually making a call to the SQS service. It waits for that period of time to see if a message has been come or not. So for example, you come to a door and ring a bell, and then how long would you wait until you say, okay, nobody's home? So that's kind of a similar analogy where you want to wait until 10 seconds, 15 seconds, 20 seconds, whatever that is, before you say, oops, okay, there's no message, now I'm gonna go back. So this allows you that flexibility of instead of making constant loops and calls, you can actually easily wait for that second. So let's say if you ring a bell and you just walk away, and the person answering the door just came out, and while you missed him, right? So this way there might be a message that is being dropped. So you say, okay, well, wait until 10, 15 seconds or whatever that is, until you go out, say, okay, no message is there, and then I'm going to come back again after 15 minutes, 20 minutes or whatever that is. There's always a possibility you will probably miss that window where there's a message that is being dropped on the queue. But again, having this long polling and having that wait time seconds until you go back and say, wait for another half an hour, 40 minutes before I make another call, it becomes very handy, and that is provided as a long polling attribute within Amazon SQS services. I found it very, very useful. All right. Let's move on. Now, this is a typical scenario as a message lifecycle on the SQS service. So as you can see, the step one is that you have a sender who's sending the message. So when in the queue, whenever you send a message to the queue, what happens is that again, because of the scalability and horizontal scalability of Amazon, what they do, they distribute that message to multiple servers, right? The SQS service that they have. In this particular case, for example, if it is being duplicated to 2 different servers, so the message is being stored in these 2 queues. That's the very first step. Now, the visibility timeout clock starts right away, meaning the message will be visible until that time runs out, right? Then what happens is step 2 is you have your receiver, right? Which is basically whose job is to retrieve the message. So this receiver is basically reading the queue. Of course, it's not reading to all services, and you will see in a few minutes when I show you the code as well. This receiver is actually talking to the queue, right? And behind the queue, there are many servers receivers which are basically tied with the same queue. Whenever you're making a call, say, hey, is there a message within the visibility timeout clock? Yes, there is a message, and it can probably return the message to the receiver for processing. In my two scenarios that I gave you, one was the image and the other one was the file upload with the registration of the user. So these are two specific user scenarios. So the file that has been dropped, for example, for registration is sitting here on one of the queuing servers. That gets sent to the receiver, and that message gets received. And then it's the job of this retriever or receivers is to actually go ahead and start processing that file. So that's step number 2. Once that file has been retrieved, then you can go ahead and delete that message. So this way it would actually avoid the duplicates of the same message being read. So you want to make sure that you delete the message. And if you have multiple receivers, then they're not really actually reading the same message again and processing it again. So this is a typical SQS message lifecycle. Again, it becomes very powerful, first of all, because the Amazon architecture is as such that they have a distribution of servers across the board, and then you don't really have to worry about the scalability. The second thing is the guaranteed of it to be delivered, because the message is dropped in multiple servers, so it is guaranteed that somebody's going to pick it up, provided your receiver and the consumer is rock solid. And you can also make sure that this is all done through the offline mode and not really getting those client server tied up during these hefty calls. All right, let's move on. Before I go to AWS SNS, let me just see if I can show you guys this. Okay, so this is the Amazon dashboard, right? Once you log in, then you can search for SQS, and here's the SQS service right here. So once you click on the SQS services, then you can go ahead and create a queue. Okay, these are built, the queues that we have already created, constructed for our production environment. But if you want to go ahead and create it, you can go ahead and click on create a queue. Remember I talked about the first in, first out delivery message. This is now something new that came out. This is standard. At least once a delivery message, ordering is in preserve. So whenever the message comes, it would actually be delivered and dropped on the queue. So there are two different ways. You can use a FIFO or you can use the standard. You can provide a name of the queue, visibility timeout. So basically, this is where you want to set how much time before the message is going to be disappeared. So you can set it to 30 seconds or whatever time frame you want to set it. Delivery delay this is what we talked about during the PowerPoint. Is if you want to have a 15 minutes delay before the message is seen by the consumer, you can set it over here. Then message retention period, so you can set it in days, seconds, minutes. So how long before the message it gets totally removed from the queue, and then it can be dropped into the dead letter pool, dead letter queues. So this is something you can set it over here as well. Maximum size, you can set it to kilobytes. Access policies, this is basically you want to allow let's say SDK or your application or the IAM role, assumed IAM role that needs to be taken on. You can set it with this access policy. This is a standard way. For example, if you want to use a JSON, you can specify your JSON, who can access your access policy or your SQS, or you can use the basic simple criteria to define a basic access policy. Only the queue owner, only the specified AWS account. Again, pre-explanatory, you can set those access policy. Encryption, provides in-transit encryption. So when the message is being sent and dropped and also received, you can have it encrypted. Again, if your own application is tightly coupled, then you really don't want to encrypt it, because there is an additional amount of latency that would be required in order to encrypt or decrypt. Dead letter queue, I talked about that, where you want to enable or disable it. This is where set the queue to receive undeliverable message. So any message that has not been delivered is going to be actually dropped over to the dead letter queue. And obviously, initially it's a disabled. You can go ahead and you can create a enable it. And when you actually enable it, then you can create a queue ARN. So you want to create a dead letter queue as a separate queue, and then provide the URL here saying, okay, whenever there is a message that has not been delivered, then drop the message on this queue. And again, you can connect a separate subscriber who's actually receiving those messages that are dropped on the dead letter queue. So this way you can do more analysis. Why did these messages did not be successfully delivered? Was there any specific reason? Whatever you may have, you can actually figure this out after those queues that are not, or the messages that are not delivered can be dropped on the dead letter queue, and you have a separate mechanism to pull those from those dead letter queues. All right. And tags, I think in my very first initial webinar, I talked about the importance of the tags. You can start billing any of the Amazon services by putting tags, and then you can start bifurcating. You can start dividing the consumption of AWS services based on the costing, and say, okay, you know, engineering, you are consuming about this much. The HR, you are consuming this much. You know, operations, you are consuming this much on the AWS. This is the dollar distribution. The only way you can do it is basically when you add tags to each of these services. So for example, if I create a queue here, I can go ahead and say, this is for engineering purposes, right? So I can put in engineering, and then I can put a value. And then whenever I'm running reports on AWS costing, I can actually filter out all the costing based on the tags. So I say, okay, well, operations cost based on that filter is this much, engineering cost is this much, and so on and so forth. So I highly recommend, AWS highly recommends to put tags for all of your services. This is very beneficial when you're coming towards the reporting of your services. Okay, so this is how you create a queue. Let me go back and then show you some of the queues that we have created already. For example, if I click on the core sync prod, this is the queue that has already been created. This is the name. It's a standard. It's not a FIFO. This is the ARN, the Amazon resource name. So basically, this is something that you can use in order to access it from your SDK services, for example, right? So you would copy it and then put it in your code base. I have set the encryption as a disabled. If you want to run it from your browser as well, or maybe as your Postman API calls, you can use this URL. I have disabled the dead letter queue. Let's go see more. When was this created? Retention period is set to 4. Delivery delay is none. Message delay is none. Maximum size is 256 KB. So these, excuse me. Down here, you can tie as an SNS subscription. So you can actually set the notification services to this queue. So anytime anything happens, you can actually send this message to the queue as well. So if a message gets dropped, you can say, okay, well, I want to send a SMS message, for example, or an email. So you can actually tie this SNS subscription to the SQS as well. Dead letter queue, again, we haven't really enforced dead letter queue. Monitoring allows you to actually view all of the data, right? So for example, approximate age of oldest message has been, can be actually see from here. What was the 5.64 thousand seconds, approximate number of message delays, approximate number of message not visible. So these are all the metadata that you can actually review in order to see how well your queue is performing. You can see, for example, at 16:30, I had about 19 messages that were sent. Same thing at 16:46. Message size, you can see it's 98.3. And again, it is a time bound, right? So you can probably add to your dashboard, or you can view in logs file as well if you want. Okay, so this is really nice to actually have that. This is the SQS default policy for now. Is our SQS services using the default policy, and the default policy allows the only the engineering folks to actually access our SQS service. Encryption, again, like I said earlier, that we haven't really implemented the encryption on this SQS service. Let's see, if you want to purge it, you can delete this. You can purge it or delete it, meaning the purge, of course, is going to drop all of the messages from this SQS. Delete would be actually delete the SQS queue altogether. Edit would, again, allow you to change any of the attribute that I was showing you earlier. Okay, let me just go back here. Send and receive messages. So if you want to manually just send a message, you can actually create the message over here and click on send message. It would actually send the message immediately. Poll for messages, and this is all real time. If you want to actually do some operations real time, or maybe one time you want to send it to the queue, a one-off message, and then that needs to be picked up from your consumer. You can go ahead and do that by coming into send and receive messages and create the message and send the message. Okay. So this is all around the queuing services. Now let me quickly jump over and see if I can show you the little bit code that we have implemented to maybe give you a little idea. Okay, give me 1 second here. So we have a consumer which is written in Python. So if you guys are a Python programmer, you can probably easily pick it up. This is a configuration Python file, right? So if you notice here, this is some of the access key and secret key region which you're using, right? So all that stuff is there. And then this is the name of the queue that we are using, right? So in this code, this application, then we are using those attributes. So for example, this is the receiver, right? So the receiver is actually receiving the messages from the queue. In order to receive the message from the queue, you have, excuse me, you have to pass a few parameters. For example, you have to provide the access key, you have to provide the secret key, you have to provide a region that the queue is created in, and also the other important thing is to provide the queue name. So if you remember, the the queue that we created was the core sync, so that queue needs to be passed in here. So once you have actually passed in all this stuff, then you can go ahead and start, polling your messages from your queue. And once the message comes in, then obviously you can go ahead and start processing it. So this is the other end of your queuing services, which is basically you are responsible for. If I go back to my PowerPoint and show you that diagram real quick. So this end right here, receiver, is basically what I was showing you in the Python, right? So it knows the queue name, the other credentials, properties, and whatnot, and it's just looking for the messages from the bucket, right? So as soon as the message drops on the queue, then basically it just goes and start processing it. Once it's done, then you can go ahead and delete the message. So this is what basically this whole code is. You can see this message is being deleted over here. Okay, so this is one of our sync process, the core synchronization process. Again, we want to make sure that our course stays up to date. So the best way is to actually, whenever there's an update to a course, we drop it on the queue, and then the rest of the stuff is taken care of by our consumer Python file that basically makes sure it picks it up from the course sync queue, process it, and then deletes it at the end. All right, so that's pretty much it for the queuing services. Let's quickly jump over to the SNS service and what is it used for. So Amazon's simple notification services is basically a very important and I think a very useful service along the others, which are also useful. But it allows you to get the notification on events, right? So like I was showing you on the SQS, let's say if something is dropped on the SQS queue, If you want to get notified via email or by SMS message, or maybe some HTTPS calls, you can easily get that tied up with your SNS. So SNS can easily pick up that message from there. You subscribe to it, and basically it sends out the message to your to consumer, depending on the subscription model. So if the subscription is HTTP or email, then it would, or SMS, it would actually use that, and provided that you have provided all the properties. You can also trigger an AWS Lambda service. So if something happens, right, you can also trigger a Lambda service. So in my original code, I can easily modify this. Remember, this is like while true, and I'm reading this. I can easily replace this code with my Lambda service, which is kind of the other third topic, kind of bleeding into it. But it kind of makes natural transition. So if a message is dropped in a queue, or if you want to process something, what you can do is you can take the message, you can read it, you can drop it on the Lambda service, which is a serverless architecture, and then Lambda basically you upload a code, the same code that I'm doing over here processing, and that gets executed. Advantages of that is basically then you're not constantly doing a while true loop and then reading the queue, but rather you're just basically distributing that responsibility to the Lambda service. The other good advantage of that is basically you pay only when the Lambda service come to live, right? In this particular scenario that we have implemented, that I'm targeting to change this, I'm actually using the server all the time, right? So it's constantly looking for it, and of course you need to make sure that server is up and running all the time. With the Lambda service, with the serverless architecture, you don't have a server that is basically constantly reading the queue, but rather you are actually getting notified by the SNS, right? Saying, hey, a message has dropped. Do you want to process this? And that's when the Amazon Lambda comes to life, and then basically start processing it. Once that processing is done, then, and the delete of the message is done, then the Lambda goes dead again, right? So imagine the cost saving that you can have if you're using the Lambda services, again, which is a serverless architecture. I would highly recommend looking into the Lambda service and in combination with the SNS. So, and again, if you're using SQS, then these all three can come together, right? So you have a queue, message drops in the queue, SNS picks it up, notifies this to Lambda service, Lambda does its job, and Lambda goes away. So it becomes a very cost-effective solution if you're using these three services together. Again, I am not using Lambda service at this point, but I do have plans to actually migrate this whole code base from a server-based architecture to a serverless architecture, which would be using the Lambda service. All right, going back to the SNS, so subscribers could be HTTP, HTTPS, email, SMS, and Lambda service. And the way you basically do it is, like as I showed you over here, kind of in transition, that you can create a topic saying, okay, it's an Amazon existing topic instance, stop rule. I mean, there are tons of messages that you can actually you can subscribe to it, and then once the subscription is done, then you would actually get a message to this queuing services. You can also directly access, I believe, if I go here. Oh, sorry, I think they have actually part of the services that you can subscribe to. So, like, for example, if I go to SQS, any of my services, yeah, so I think you can probably go ahead and start subscribing it to this queuing services. SNS would be available in many other services where you can go ahead and start subscribe to the SNS and start receiving the messages. Let's jump over to the last topic of today's webinar. That would be the Lambda service. I've kind of briefly touched base on the Lambda services, right? So these are some of the services that I'm actually using it. Let me just go here. So the Lambda service allows you to actually write a small function with its some of its own parameters. the idea again is that you create a function or a code base that can actually sit here in the within the Lambda service, and then you define the triggering mechanism, right? And then you actually start executing the code, right? So this is just a simple code that we have actually written here, and then you can, or you can write a code, Java code outside of it, and actually upload a zip file. Let me show you that. I think it was just this sample code, right? So this is a sample Java code that was actually written in Java, and then this was actually uploaded via the zip file. So once you have written the zip file, you have to have a proper zip format for Java, and then actually upload that. Once you do that, you can define the runtime environment. For example, these are all the environments that are supported by this by Lambda service. I have chose Java 8, but you can use Python and different languages, and .NET is available as well. This is the main method, which is the entry point to this code base, right? So if you want to start, executing the function, what would be the entry point to this? So you just define the entry point. You can actually get a help. See right here, you can tell the Lambda runtime which handler method to invoke by setting the handler parameter on your function configuration. The following handler formats are supported in Java. So package name, class, and the method. For example, com.main and the handler, which would be the actual method name, calls the handler method. So in my example, this is the package, obviously, right? And then you defined the actual method name, which would be the say hello handler, right? Then you can also define your function is allocated CPU proportional to the memory configured. You can allocate more memory if you have to, but again, you will be incurring some cost there. Use an existing role. This is all part of the IAM. If you want to actually allow a assumed role within the IAM, then you can also set the existing role, or you can create a new role. Rule creation, you can define the role over here, and then also define the policies. So this is all something that I've already covered in the last IAM role policy sessions. So it gives you a very basic interface where you can go ahead and specify the runtime environment for your Lambda service. So once this is all packaged and done, again, like I said, and if you want to tie this with your SNS, or maybe this is something that you may want to probably just call it from your HTTP method. So a good example or use case would be similar to what I was mentioning earlier. Let's say if if you want to return a catalog to your vendor partners, right? And the catalog might be a list of all the products that you have in the system, and you don't want to allocate a server for that because this might be something that a vendor may request on a need basis. So what you do is basically you make a call every that often, maybe once a day or something like that. For that, you don't really need a server. What you do is basically you can go ahead and create a Lambda function, and that Lambda function would actually retrieve the catalog from your database and return to the callee. And that Lambda function comes to live only at the time when there's a call from a vendor. Other than that, this Lambda function just stays dormant. You don't really have to incur any cost. So it becomes very cost-effective solution. And you can update this code base any which way time you want by just dropping a new jar file, new zip file to the Lambda function. It becomes very, very cost-effective. And this is the crux of the serverless architecture within Amazon. Okay. And you can also kind of think about this as a microservice solution, right? Because you can have small microservices that are defined as a Lambda functions. Those microservices Lambda function can be dropped here. and you can have tons of those. Distribute those functions to your partners, vendors, or even your applications, and those applications are basically calling these functions. The other advantage of this is, apart from the cost effectiveness, is also the scalability. So these Lambda functions are horizontally scalable, meaning that you don't really have to worry about what if I get a load on my servers, then would this actually scale? Lambda services are horizontally scalable by Amazon. So as the load comes in, they would actually spin off more machines in the back end. You won't even have to worry about it. It's all done under the hood. So cost effectiveness and load balancing is all done and taken care of the Lambda services, Lambda function. Do take a look at this Lambda services. It is very powerful in serverless architecture, and it frees up microservices and deviates from the monolithic application architecture. Cost effectiveness is definitely there, and also from the load balancing and performance perspective. It does, like I said, support not just Java. It supports many languages that you're familiar with. You can easily implement those in those appropriate languages. And again, there might be some changes. If you're doing a Java, you have to upload a zip file, versus if you have a Python, then the function name the upload of that function might be a little differently. So you may want to probably look into it based on the need. All right, so that's pretty much it from my side.